All right, Hacksters, welcome to Thursday, and today we've got something super cool coming on. Let me double check my audio first, actually. No, there we go. That's much better. Okay, so a while ago, we introduced you to the Jetson Nano JetBot, and this is a cool robot designed by NVIDIA to showcase the capabilities of their Jetson Nano developer kit, which is designed to make it really easy for developers to create AI solutions, including robots and other things, which of course is my favorite. So let's take a look. What we're doing today is we're going to try and assemble the JetBot despite not having all of the pieces, the original pieces, but I believe that I've rustled up enough that I'll be able to put this robot together, and then later on we'll be able to program it, and it'll be super cool. So not only might you have seen this on our video channel before, this is linked in the description below. You can find our unboxing from May of last year. You can see why the pieces may have gotten a bit scattered, as well as everything else. But also, we ran this AI at the Edge challenge with NVIDIA a little while ago, and you can check out all kinds of amazing projects that people made with this. Look at these autonomous machines and robots. We've got things for intelligent video analytics and smart cities. And then we also have artificial intelligence of things, AIoT projects, including Clean Water AI. Oh, I love them. They use artificial intelligence to detect pathogens in water and enable you to instantly update your models wherever you are in the world so that you don't have to invest and wait for improved test strips or whatever. Whenever a new type of pathogen is detected, you can immediately start detecting it in your water and respond accordingly. Also, Mixpose is a really cool one that teaches you yoga with AI. There's also a really cool one for the Social Impact Award that was a reading eye for the blind. So check these out. It's just Hackster.io/contest/NVIDIA. Again, linked in the description below. So these are some previous ways you might have become familiar with the Jetson Nano, but in case you don't know anything about it yet, you can check out the other link, the first one down below, for all the specs. Let's just check these out really quick. We've got the NVIDIA Maxwell architecture with 128 NVIDIA CUDA cores. You've got a quad-core ARM Cortex-A57 MP core processor, 4 gigs of LPDDR4 RAM. You've got 16 gigs of flash memory as well, and all these other attributes of the developer kit. So much cool stuff. You do need an external chip for Wi-Fi, but the JetBot kit includes, I believe, a Wi-Fi USB dongle, and I have a little one that I'm going to be using. The reason we bring this up right now is because they're doing a developer survey. So go to surveymonkey.com/r/Jetson-nano-survey. I'm obviously a little ways into it, and I haven't actually used the developer kit yet. So I'm waiting until I give it a try in order to answer this. And that's partly why I'm constructing this robot. But if you've used the Jetson Nano, maybe for the AI at the Edge contest or for something else, you can go fill out the survey now. They just want to know what the developer community is up to with the Jetson Nanos, what your opinion is about how to use it, what you would use it for, how easy it is to use, and things like that. All kinds of cool stuff. So if you first get the kit, let me show you what we have here. I'm going to switch over to my other camera. So we have a bunch of pieces from it from before, and it says to get started, visit nvidia.com/Jetson-nano-start. And that first link takes you to this page. The Getting Started with the Jetson Nano Developer Kit. And this just shows you how to use the kit on its own without any of the extra robot parts. So if you just have the Jetson Nano and you haven't broken it out of its box yet, this is a great place to start. And you should have this little card inside of the kit as well. So you've got a micro SD card slot for the main storage, 40-pin expansion header, just like on a Raspberry Pi. You've got micro USB port for 5-volt power input or for data, a gigabit Ethernet port, 4 USB 3.0 ports, HDMI output, DisplayPort connector, a barrel jack for 5 volts in, and a couple of MIPI camera connectors. Cool. Oh yeah, that's right. It also comes with a little folded paper stand inside of the box is sort of made of that. And I'm going to skip all this stuff that you might do with hooking it up to a display and USB keyboard and mouse, because we're just going to be putting it into a robot, which I think is a lot more fun. So once you have decided to work with the JetBot itself, you can go to the JetBot wiki, and if you just look for this on Google or click the link in the description below, it's very clearly laid out. The first 4 things you want to do are make sure that you have all the parts in the bill of materials, which is what I went through before this video. You want to open up your hardware and software setup links, and then you'll be able to run through the examples. So without further ado, let's check out all these bill of materials and make sure that we have everything that we need. And I'm going to explain how what I have kind of differs from the original kit. So first up, you have your Jetson Nano. We totally have that. Yay! In a little developer kit. The next thing they say is a micro SD card. Actually, when we first got this, they shipped us a micro SD card with a demo built in. So I'm going to explore that off screen once we get this set up. We also have a couple of motors and a motor driver. They link to Adafruit for those. I didn't have separate ones. I actually have this existing AdaBot kit from an old Adafruit AdaBox subscription kit. And I sort of took it apart a little bit. There was another tier on here, and I'd also put an Adafruit Cricket on the top. But it has these same motors that they mention, the same little wheel attachments that they mention, and a little caster in the front, just like the JetBot kit describes. I decided not to take this apart because it works pretty well as is with the existing caster mount. I didn't know if this would adapt itself to the JetBot chassis. And so instead, I've just noticed that it will fit perfectly on there, and I'm just going to attach it to there with foam tape, double-sided sticky foam tape. And here is the motor controller. It's just an Adafruit Featherwing style motor controller, and that's going to get hooked up to power and to our motors. Mike says, can you imagine a Jetson Rosie? Hanna-Barbera, y'all. That'd be awesome. Yeah, like on the Jetsons. Duh. That makes sense. Let's see what else we need. We need a caster ball. We've got our motor driver. We need a battery. So ideally, you would have 2 5-volt batteries going in. Now, I've dug up a couple of USB phone bank style batteries, and these are both a little bit too large. So I'm going to be digging around a little bit more to find ones that are suitable for this kit, because they just don't fit. But we can either, these would do in a pinch. If I needed to adapt the size, I could somehow make like I could just pile them on there, but I'm going to try and find a better fit before we actually run this. Let's see, we have, the original kit comes with a USB cable pack, which is just 2 little USB cables, USB-A to micro USB, and I don't have those, but from what I see in the tutorial, it looks like you're going to be cutting them up anyway, and so I have a couple of sacrificial little USB-A to micro USB cables. Then one thing is that they say in the kit that they give you, it's a right angle USB connector, and I don't have that, and so I might have to do a little finagling so that it doesn't block any of, for example, the Ethernet port on the Jetson Nano developer kit. The actual JetBot tutorial includes a Pi OLED display and header, and those are so that it can easily show you the IP address where it's connected to your network. And while that would be really wonderful, I don't have those little OLEDs on hand, and so I'm going to have to just improvise. That might be a thing for another day, but we'll start with everything else. And I feel like I can find, I can run commands on my own machine to find what devices are connected to the network and their IPs. So I figure that if I just scan the network beforehand, then plug in the JetBot, and then scan the network afterwards, I should be able to find the IP address that way without having to hook it up to a monitor and all that good stuff. If I can never do that again, that would make me so happy. So let's see. What else have we got here? We've got the chassis and camera mount, which are these 3D printed parts you see. These ones you can find online. I printed these in the Hackster office. That's why there's beautiful blue color. So on brand. I've got a little bit too much brightness here. Sorry about that. Ooh, there we go. Detail. Imagine that. And then here's your little camera mount. I was sort of tempted to put the camera on it like so. But actually, it's going to be facing downward toward the ground. So it's going to be mounted like so. And then the cable goes over it toward the Jetson Nano developer kit. So let's bust out the... Oh, yeah, there's also a power supply. They recommend this one from Adafruit. And that's what I'm going to be using. Focus. There we go. Yes, beautiful. Okay, cool. How's it going, Cases? That's awesome. Yeah, let's open up this developer kit. Let's see where we end up. I love these containers. It's very similar to how the Google Voice and Vision kits originally came. I'm going to show you a cool little paper situation. Oh no, it's gone. I guess I removed the cool little paper stand from inside of here. But anyway, here we have the Jetson Nano developer kit. And this has, as you can see, a massive heatsink. This thing is not going to get overheated. And underneath that is where the Nano SoC actually is. Or it might be a system on module, actually. And so if you unscrew these from the standoffs and lever it out of here, then you'll have the Nano module on its own. And that actually is something that they recommend doing at one part in the robot process in order to attach a separate Wi-Fi module underneath here. And, oh, hey, we already have a little SD card in there, so maybe it's already set up. I might have done something with this before. It's been a long time. As I mentioned, the last video we did, this was in May of last year, so we'll see. But yeah, let's take a look at the instructions really quick. Again, all these, we're going from the main JetBot page on GitHub, and what I just looked at was the bill of materials page, and now I'm going to be looking at the hardware setup page. And as I mentioned, there's a point at which they want you to lift up and remove the Jetson Nano module from the developer kit. And they show you how to do that. That's so that you can attach a Wi-Fi module underneath. But as you see in the bill of materials, they have a couple of places where you can use different options. So for example, you could use this one Leopard imaging camera, or you could use a Raspberry Pi camera V2 and a lens attachment. I don't have the right lens attachment, but I do have a Pi camera. And for Wi-Fi, you can use the Wi-Fi card and antenna like they're showing here, or you can use a Wi-Fi dongle like the one that I have here. And they talk about how they're tracking an issue with the Linux driver for the below Wi-Fi dongle. So they're very involved with the developer community and really going to try and solve any problems that you run into. Also, you have a couple of different options for wheels and things. As I mentioned, I'm using the ones that came with the Adafruit kit. I'm actually not sure if they're 60 or 65 millimeters, but close enough either way. And then some assembly hardware. For adhesive pads, I'm just using a bunch of foam tape, the double-sided sticky foam tape. So let's get started. I'm going to be following this hardware setup page that we just looked at that's linked from the main JetBot page. And I've got my little pliers, my little wire strippers and whatever, screwdrivers, soldering iron, and all that good stuff. So the first thing you're supposed to do is clean the 3D printed parts. I've pretty much done as much as I could on that front, but the print sadly did not have that great of quality. So as you can see, some of these screw holes have kind of gotten messed up. But that's another place where this other kit comes in handy, which is that I don't have, like, these screw holes don't match up to anything anyway. So it really just makes sense for me to use this double-sided foam sticky tape. This is what I'm talking about. This is like the 3M brand, but it comes in a roll. It's sticky on both sides. You apply one side, and then you peel off the protective backing and apply the other side. And basically what I'm going to be doing is cutting it in half and putting half over here and half over there. But let's start earlier in the process. Let's see. Step 1 is clean the 3D printed parts. Step 2 is mount the motors. We've already got those mounted into this AdaBot chassis, so we're kind of ahead of the game. I don't know if anyone is mining bitcoins with this. I'm sure someone has tried it. I'm sure you can find evidence online. Yeah, not exactly my bag, but I don't blame you if you're interested. Next up is to solder the motor driver. So I've already actually attached the screw terminals and things to this motor driver for a previous project, and they have you add a couple of header pins. So there's 2 over here on the extreme right that you would add ordinarily, and those are for, what are those for? SDA and SCL. Okay, so for communication. They have really nice, let me show you these photos, they're really nice. You just click on these and you get a nice, big, beautiful, high-quality photo. And then they have you put another 3-pin header down here at the bottom for ground and voltage. And then over here on the left is where you would put one of those stripped USB cables for power to the motors. And then at the bottom, you connect your motors directly. So I'm going to go back to the instructions. And what I have here is that I've already actually attached headers to this, so I don't need to add any more headers. I can just grab these 3 or whatever. They say to be careful. If you are just adding a 3-pin header, you want to skip the pin on the end and start at the second one in. So it's 2nd, 3rd, and 4th pins. All right, what's next? Next, we need to strip the motor driver power cable. Okay, so we're going to end up with ideally a right angle USB-A plug on one side, plug on one side. I don't have a right angle one. I'm hoping I can get away without Ethernet because that should allow me to use just a regular stripped micro USB cable. I do this all the time for projects when I want to power them off of 5 volts and then like solder the other end. I've done this with Raspberry Pis a million times. I'm just gonna cut this off. And then, so I'm left with the USB-A end and strip this. They say to strip it 3 centimeters, which I think is a little bit extreme, but sure, let's go ahead with that. There we go. Making sure to, oh no, I did that too tightly and now I've cut off my wire. Okay, so I usually try to cut in a little bit and then sort of just pull it off so that I don't run the risk of breaking my wires. I still lost a little bit in that one. This is a bit of an unusual one. You can tell that it's really cheap. It doesn't have any shielding, and the wires are really not very protected inside of there. Often they'll have a sort of metal weave protecting it, or at least just a sort of foil shield. And the one that they link to in the JetBot instructions definitely has that. So it's a little bit easier to strip without damaging the wires. Come off of there. If you cut through most of the way, you can usually pull it off. Haha, like that. Without damaging the wires. And that's another little sort of janky trick that I use for these things. And I can kind of cut off the rest of the shielding here. Let's do a little bit more. I kind of try to go all the way around, but not dig in too deep. The sort of conundrum here is that if you squeeze too hard, there we go. Okay. Oh, I managed to get through the shielding on that one again, but that's okay. Another thing that you can do is sort of cut through a little bit and then grab onto it with your fingernails, and then you're pretty guaranteed not to strip the wire. But you might mess up your fingernails. You just got to be prepared for that. Oh, I should really just get a better wire stripper. I'm going to do this off screen so I can focus a little better. There we go. Maybe I need glasses for like close up so that I can see what I'm doing a little better. When you're trying to do it in front of a camera, it's not always optimal. There we go. Okay, so we have these two little wires. Twist them together. They do have this little sort of nylon stuff core in them for tensile strength, and so I'm just going to burn that off with a lighter. Woo! Cool. And I don't need quite this long of wire, so because I'm just going to be inserting it into those screw terminals, as far as I can tell. Where do we solder this on? Yeah, it gets screwed in. I'll show you here. So we have stripped the motor driver power cable, and then we're supposed to mount the motor driver. We put the little stripped cable in there, and then you put it into the screw terminals. So for this, what I'm going to do is I'm going to reinforce these little wires because they're so sort of wimpy. I'm going to tin them with solder to make sure that the screw terminals can kind of grab onto them. Get my third hand in here. Lead-free solder is always a little bit more difficult to wrangle, but it gets there in the end. All right. So with those tinned, they should stick into those screw terminals a little bit better. And this one is labeled with a plus and minus for which one goes where. So we're going to... Oh yeah, I don't screw these in yet. They have to go in the chassis first. Oh, ho, ho. Okay. I should make sure which side of this is the front. It looks like the side with the camera mount, aka the flat side, is the front. That makes sense. That's where the camera goes. So, and the motors kind of point back from there with the caster in the back. All right. So basically, this is going to be the front. The motors sort of point back toward the caster like so. So that is indeed the correct orientation. Yes, we did already talk about the survey. I'll show you once more before we dig in. It's surveymonkey.com/r/jetson-nano-survey. It's linked in the description below, and they just want to get an understanding of how the developer community is using the Jetson Nano and what for. Okay, cool. Pulling back up my directions. We are trying to... I scrolled all the way down to the bottom for that. Okay, mount the motor driver. We open this, turn it over, and on this indented side, we're going to take our strip wire. They've got a little piece of heat shrink on there. It doesn't seem like there's any real reason for it. It doesn't seem to be doing much, so I'm going to push that in through. Okay, it comes up through here, and then around through there. Oh, wait, no, it goes the other way. Like so. All right. The motor driver goes in here. It gets attached. Oh, looks like I have some solder in there for some reason. I wonder if I lent this to someone who didn't know how screw terminals work. That's very strange. Huh. Well, alright. I guess I'll solder to it then. Wait, can I get that out? Yeah, no, that's straight up soldered in there. That's so strange. Why would you do that? Okay. I guess that's my life now. Wrestling with my desk items. Let's get this lined up. And I guess I'm going to go with the flow and just solder this back on. It's very strange. I'm just going to try and get this lined up with my hands. Sometimes that's the easiest way for me. It's taking the solder a minute to melt. What if I just got... What if I just grabbed a solder sucker and got that out of there? Can I do that? Might need a little bit of solder on there for thermal contact. Oh no! It really doesn't want to melt. What is going on here? Well, I guess we'll just try and solder it to as is. Actually, my USB cable can fit through these. No, it can't. So I have to solder with it already attached to the chassis. Okay, let's do this. It's gonna be horrible. But I guess that's life. Sometimes you end up with a really weird situation. Just gotta roll with it. I'm going to accordingly cut this a little bit shorter so we have a little bit more stability with it. But it's really not optimal. It's really melting the plastic in it. Ugh. The trouble is that there's a large chunk of solder in there, and it's kind of acting as its own heatsink. Because there's also like large pieces of metal that are ordinarily designed to clamp down on a metal contact. Let's see if the other one will screw down though. That'd be nice. If I have to solder to both of them, I'm going to lose some faith in humanity. Come on. Oh, yes. Oh, no. No, what's happened? Doesn't go any further. I guess it's expecting some thicker wires, huh? Maybe that's why I soldered to it before, but that seems just barbaric, honestly. Okay, I guess if the other one's already soldered, we might as well do this one too. I'm sorry. This is not how it's supposed to be. I'm hoping we'll be able to get through this whole thing and get to a kind of workable state tonight. It's possible that we'll have to take a break and come back tomorrow, but if so, we'll do that. And you'll be able to watch it at your leisure. Let's get that in there. I'm just trying to hold the soldering iron in place so that the contacts heat up enough to solder to. Not having very great luck, though. They're sucking up all the heat that I can give it. What if I just make a big, hefty chunk on the wire itself and then screw down on top of it? I think that's what I'm going to do. So we've got this kind of big blob on here. And if I cut off the rest of the wire, then I should be able to clamp it. Oh, what a mess. Okay, so that blob is too big. We gotta get a happy medium. There we go. Okay, that's pretty good. Oh no. This is turning out to be the surprise difficult part of the assembly. Well, only because I'm using a part that I hadn't realized had been damaged before. Put that blob a little bit smaller again. This is what happens when you let your developer kit sit around for a year. Okay. Let's get this attached. Okay. We have positive connections. Thank goodness, huh? All right, so let's see. Now we've got this in place. I'm not technically supposed to have these headers on here is the thing, but I'm not going to remove them just now. I think we have plenty of space under here because we have some extra area. I think the battery's supposed to be in here. The motors are supposed to be sort of in here, and they're not, which means that we have some extra space for the motor driver. So let's see what comes next. We have secured the red and black wires to the power terminals on the motor driver. Now we need to secure the motor to the driver, or driver to the chassis using self-tapping screws. And instead of that, I'm going to use foam tape. I could use screws if I had some, but I don't think they were included when I was shipped the kit. So instead, we're just going to use tape eventually. But for now, what we're going to do is attach the motors, and those go into this end. Let's see if those are marked or not. M1 and M2. They're not, but they have another of those lovely diagrams. So let's take a look at how that's supposed to look. It looks like our wires, the motors get attached to the left one, and then the right one, and the red wires are on the left. Okay, cool. There's a note on here, though, that says, we made a slight mistake. The red and black wires for the left and right motors are actually flipped in the image shown above. This will not cause damage, but the motors will spin backwards. Please flip them to the correct orientation. So actually, the red wires should be on the right, the black wires should be on the left, but it sounds like the motors are actually in the right order. So let's take a look at this. I'm going to show you what I'm doing with my hands, and hopefully that will correspond to what it should. So, assuming everything were upside down, because the entire robot is supposed to be upside down right now, we have this motor coming through. A little bit wire juggling here. I'm actually going to pull it around the front. Like so. And same with the other one. So I don't want them to get squashed underneath the chassis. So red wires on the right. Let's do this. Thankfully, these screw terminals have not been messed with. Why are you not going in, though? There we are. These little motor drivers are super cool. And they're so compact, they sort of fit anywhere. And then once again, we put the red wire on the right. Nothing's shorted. That looks good. Okay, and then we should attach this in here. I'm going to flip it around. So once again, okay, it's supposed to go in this direction though. All right. Okay, cool. So it's supposed to be attached like this. Going to figure that out later when it's time to like put everything together. For now, let's see what comes next. So now they want us to remove the Jetson Nano module if we're going to put a Wi-Fi module underneath it. We're not going to do that. We're just going to use a plug-in one, a USB one. They do want you to attach the developer kit to the chassis using self-tapping screws. The deal with self-tapping screws is that they have a pointy end and they will just bite into the 3D printed material, which makes it really easy to attach things. But I think somewhere along the way, we did not quite get that hardware. And so instead, we're going to be using a fair amount of foam tape. Let's see. So here's our module. And which way on does it go? It goes with the USB ports to the left, assuming that the camera is the front. Cool. Port side. Oh, I wonder if I do have some screws that would fit in here. It seems like such a shame when it's got this beautiful like standoff situation. I'm gonna run and grab and see if I can find a few pretty screws that we can throw in here. But you know what? I might have some for servos. Haha! I totally do. Here we go. These are about the right size. And I'm not going to be using it for these servos, so I'm just going to put 2 of these in here, though. I can put them in diagonally opposite corners. That way I'll be able to remove it and mess around with it if I want. I'm going to use a sturdier screwdriver. There we go. So how about over here and then in the opposite corner. So these are just sort of regular screws that will dig themselves into the plastic as I screw it in. Ooh! If I don't lose it first. John says, it is so satisfying to see a new robot being born. I totally agree. It's very satisfying to do this. And Yanni says, this totally looked like an owl for a moment. I'm really curious where you got that idea. Like, I'm as pro owl as anyone else, but I can't say that I see it. You should post a diagram. You should make a diagram and post it. And then we'll all get to have a look. So these ended up being a little bit long. There's a little bit too much resistance in order to be able to screw it in further. Also, I'm a little bit afraid that it would come through the bottom here. Let's try a little bit more. We can do this. Just gotta use some elbow grease. Oh! You know, I'm a little afraid of stripping this screw, actually. So let's put it in that far. This should probably be enough to hold it fairly securely. And if I want, I can put some spacers on later on. In fact, I think there's some that came with the original JetBot kit that I could use. Go in there. Go in there. Go in there. Making sure not to contact any of the electrical components around it. Yeah, that's pretty good. Cool. What's next? Antennae. We don't have antennae for the Wi-Fi module because we're using a USB dongle. Mount the ball caster. We've already got that attached to our JetBot kit. It's on the bottom there. So the way that this robot is going to drive, I assume, is tank steering, which is this kind of thing where you have, like, you drive both motors forward, it goes forward. It goes forward. You drive both motors back, it goes back. If you do one each way, then it goes left or right. And then this back one just sort of helps support the weight and will roll whichever way as guided by these other wheels. What's next? We're supposed to attach this Pi OLED display. As I mentioned, I don't have one of those, but I can use the ARP-A command in my Mac's terminal to determine what's connected to my Wi-Fi network. So I'll run that scan before I power up the device, and then afterwards, and I'll be able to discern by process of elimination which one is the robot. Wire the motor to the Pi OLED display. Oh! That's interesting. So the way they have the wires routed depends on having that OLED display. That's not optimal. So I guess maybe two of those wires were for attaching to the... Mount the camera. I'll come back to that. As I mentioned, we're doing the hardware today. Software comes tomorrow or later. And so we'll see what happens here. Mount the camera. Let's do that. Attach the camera to the camera mount using 4 times self-tapping screws. Again, we're going to use our good buddy foam tape. So I think actually, is this supposed to be mounted to the... Oh, yeah. The chassis is supposed to be attached to the wheels at this point. So I might as well start the foam tape at the bottom and work my way up. So here we are. Beautiful foam tape. I want about this much. I'm going to tear it off there. Lovely thing about foam tape, you can pretty much just tear it wherever. Then I'm going to go a little bit more precise and cut it down the center. And stick it on here. Do. As for this guy, I'm not quite sure how I'm going to do that one yet, but I'll figure it out in a bit. It's a little more complex, as I mentioned, because, ooh, no, we've got a little wire coming apart here. That's no good. I should attach some electrical tape or something so that that doesn't get pulled apart, because that will lead to unexplained robot dead in the water scenarios, which is nobody's favorite. Not mine, anyway. If that's your favorite, you're weird. Okay, that'll do for now. But later on, I'll probably use some hot glue or something. I could do heat shrink, but whatever. Let's pull this off. Because what I figure is I might build it this way and then mess around with it later on to get a different robot configuration. Who knows? It could be fun. Let's get this all situated and attach it down. Make sure it's evenly centered between the wheels, not brushing against either of them. Oh, it's already attached itself. Come off of there. This foam tape stuff is great. Once you get it lined up, it just sticks basically forever. And it's cheap enough that you can just sort of rip it off and reconfigure as much as you want. There we go. Okay. So now that's pretty well in place. Great. And the next thing we were going to do is attach the camera to the camera module. Once again, we don't have those self-tapping screws, so we're just going to foam tape it on. It goes like this. You can see where those screws would go. And we can pretty easily line that up. I'm going to do 2 layers of foam tape, because there's a little bit of a gap in there and I want to make sure that we get a good solid connection. So taking these 2 pieces, sticking them back to back. Take this, put it on here. Actually like this, yeah. Pull off the other side. Attach this here. Lovely. Trying to be a little bit gentle with it, but that gets the job done. Let's get all these things out of the way. And attach the camera mount to the chassis. Insert the other end of the ribbon into the Jetson Nano developer kit, and then we can tuck the ribbon cable against the heatsink to organize it, as shown here. Nice. So they put a little loop in it, basically. Oh, that's so nice. Look at this. If only I had those screws. Oh, but this connects. I can put some tape down there. That's about the right width already. On the bottom of the module. Once again, we are here today doing this because there is a Jetson Nano developers survey linked in the description below. And today is basically the last day to do it. Tomorrow's the deadline. And by today and tomorrow, I mean Thursday is the last day, pretty much. Friday is the deadline. So be sure to get it in the next few hours. They just wanted to hear about what developers are doing with the Jetson Nano. What you think about it, how easy is it to use, how's the price point, and your other opinions about it, as well as what other platforms you use to design with. So I've pulled up this little connector here. I'm going to make sure that I connect the camera in the correct direction. Okay, so the silver side goes into the connector, and I'm going to make sure that I sort of twist it the right way. Good. We have that same sort of twist happening. The silver contacts are on this side. I'm going to make sure this is up. Push it into there. And then we push down on the connector to lock it in place. All right, and then how did they do that little twist and tuck thing? You're supposed to sort of twist it under the heatsink to organize. Yeah, that looks pretty good. Yeah. So, yes, I agree, Yanni. The world does need more robot owls. Here we go. Richard has linked another board. Jetson AGX Xavier Developer Kit. Sounds cool. I will have to check that out afterwards. So let's take a look at what's next in our directions. We've attached the camera. And we don't have this wide angle sensor for the camera. Actually, I wonder if at this point you'd be able to use the Raspberry Pi high definition camera, which is out. It's an HDE camera for the Raspberry Pi. It's super fancy. It might make this even cooler as a robot kit. Again, I don't have batteries that fit right now, but we can sort of test things, pardon me, using a USB cable extension. Organize the wires. All our wires are already kind of tucked away, with the exception of these ones in the front. Those could be better organized. Again, I'm going to figure out how to mount this well so that we make sure we don't get any shorts. The screw terminals are doing a pretty good job of isolating the electrical contacts from the metal chassis of the robot here, but obviously this is not optimal. However, we have a Jetson Nano developer kit. Let me zoom out a little bit. Oh yeah, there we go. So we have a Jetson Nano developer kit attached to a Raspberry Pi camera with the ribbon cable. We have it all attached to the Jetson JetBot robot chassis. We have that attached to this old AdaBot robot chassis because it already has, I put this together a while ago. It's already got your two DC motors of the same type that are used in the JetBot kit, the same little robot wheels, and the same, well, compatible little caster. It's the same format of robot, so I've just attached it on top. And everything kind of fits together nicely. Presumably, this angle is going to be a little bit off because instead of the motors being up here, they're going to be down here. So you might have to compensate for that if you were doing it this way. Although, if you were building this robot, honestly, I'm not sure why you wouldn't just order the parts from scratch. I'm just doing it this way because we have a survey going on, and I wanted to do a video about it. And I've never put the spots together before, so now I finally get to play with it. And we've got the little micro SD card already set up in there. I'll probably hook this up to a USB mouse and keyboard and a display just to see what's on it already, because I have no clue. And then we'll figure that out and make it do some cool robot stuff. What is left in this? Okay. You organize the wires, and then you have a finished JetBot. Fantastic. So it looks vaguely similar to that. Once I get a matching battery in place, it's going to look more like that and be more autonomous. Oh, yeah, look at this. You can see where they have the right angle USB connection over here for power. Now, that's interesting because I thought it was kind of unusual that we were connecting. Huh. Wait a minute. Okay. So I think this is just going to be powering the Nano kit. It's a little ambiguous. Oh, here we go. Okay, so there's a wire from the battery to the motors, and then there's also a wire from the battery to the Jetson developer kit. That makes more sense. Okay, so they're two identical little wires. This one on the top is the one that we just stripped in order to connect it to the motor controller, which makes sense. Usually when you want to have your motors on a separate power source or a separate port of the same battery versus your developer kit. You want to have them separate because the motors are usually going to pull a lot more and also variable amperage compared to your developer kit, and you don't want to overwhelm it or do anything else untoward. Okay, so once we get the battery in there, we will also add another little micro USB cable going from the battery to here. And as they mentioned, if you just use a regular micro USB cable, like so, you run the risk of blocking the Ethernet port here. But I think that most of them actually are just fine. Like, look at this. I can totally plug an Ethernet cable in here at the same time. It is nice, though, if you're building a robot, not to have a bunch of wires sticking out the side. But the Ethernet cable kind of does away with that dream already, so yeah. It's just fine to use a regular micro USB cable. And then we can plug them both into a battery eventually. Here's the one for the motors. And here's the one for the Nano kit. Doop. And we'll slide the battery in there. And it'll all be nice. Okay, so we have completed our assembly. We'll be back at some point with an actual software exploration of this kit. In the meantime, be sure to go take the survey that we mentioned here on SurveyMonkey and check out the designs that your friends have already put up for the AI at the Edge challenge that we ran before. Tons of cool ideas here. The winners are just amazing. I love all these ones in the AIoT categories and the smart cities and social impact categories. So cool. Tons of ideas. Check out the link below for more information on the Jetson Nano Developer Kit itself. And you can find all of this stuff on the JetBot that we just assembled on GitHub, also linked below, as well as our unboxing. All right, that is all for me on this Thursday night. Thanks for joining us. We'll have more robots and stuff. Tune in anytime. Unboxings, all kinds of developer resources. I'm your host, Alex Glow. Have an awesome rest of your Thursday, or whatever day it is for you. And as always, hack on. Robots.